right, so let's take a look at vectors, but now in 2 dimensions. So when we think about vectors, we got to remember they have a magnitude and a direction. And so I got this wonderful equation up here, 3 plus 4 equals 5. And you might be like, that doesn't work, Mr. Foster. But wait, what if I go 3 plus 4? What do I get? I end up with 5. Yes, so vector addition is a little trickier than the old addition we used to do, but some parts of vector addition do work out okay. So I might do 4 plus 3 gives me 7. Or I might do 4 plus 3, 4 and a negative 3, I guess, but 4 plus 3 gives me 1. And so yes, we can still do vector addition just the same way as we did our regular addition if we can only do it in like 1 dimension. So how do I set up a problem where maybe I have 4 this way and 3 this way? How do I figure out what that value is? So we need a plan. So let's make a plan. All right, so we have our plan. So our plan is this. We're going to start with our vector. We're going to break it into an x component and a y component. We only want to know how much of it goes in the x, how much of it goes in the y. So I have to resolve it, this is called, when I split it into those components. I can then do any math I want, whether it's just adding them or whether it's motion equations, like our equations on the sideboard, and then I can put things back together and I can combine those components back together. So the first step we need to learn is we need to learn how do we resolve a vector? How do we break it into parts? So let's reset up an example with resolving. All right, so now we're going to do resolving vectors into components. So we have to kind of define some terms here. So a vector, remember, is an arrow with both direction and magnitude. And so we indicate the direction with the arrow symbol. The components of a vector, the components of the vector are the kind of legs that would make up a right triangle. In other words, if I wanted to get to this point from here, I could take vector A, or I could do it using the components of A. Both will result in me getting to that same point. Another way to think about it is that the components are telling us how much of this A vector is horizontal and how much of this A vector is vertical. Okay? So how do we find these 2 parts, the AX, the X component, and the AY, the Y component? So how we do that is we're going to have to go back to our trig a little bit, so we'll have to remember Sohcahtoa. So if I want to find the X side, this is the adjacent side to the angle, and I have the hypotenuse, which one is going to work for me? Well, the one with the adjacent and hypotenuse is going to work. So I can say that the cosine of theta here is going to be the adjacent, which is A sub x, the x component, divided by the hypotenuse, A. Solving for AX, I find out, multiplying the A over to the other side, I get A times the cosine of theta. For the y component, I'm now on the opposite side. So in order to find the opposite side, I'm going to choose sine. And so I see that the sine of the angle is equal to the opposite, AY, divided by the hypotenuse, A. And I find out that the y component is going to be A sine of theta. So these are the 2 equations that we're going to use to resolve into components. Now, AX and AY aren't always going to be cosine and sine. You have to look and say, well, which one is opposite, which one is adjacent, okay? Now, let's give one of these a try. Let's try one out. So let's do the example there at the bottom of the page. So it says, a woman takes her dog Rover for a walk on a leash. To get the little pooch moving forward, she pulls on the leash with a force of 20 N. N, what's the N stand for? Any good memories out there? Newtons, you got it. 20 newtons at an angle of 37 degrees above the horizontal. So if this is the horizontal, it's 37 degrees above the horizontal. How much force is tending to pull Rover forward, and how much force is tending to lift Rover off the ground? Okay, so I drew my picture, so I have my 20 newtons, 37 degrees above the horizontal is my angle, and I want to know how much is pulling horizontally and how much is pulling vertically. So this side down here is adjacent. So adjacent means I'm going to be using my cosine. So I know the cosine of 37 is going to be my adjacent force. We'll just call it x in this case, divided by the hypotenuse 20. So I can do 20 times the cosine of 37 equals x. This side over here, I'll call it y because it's going to be my y component. It's opposite, so I'm going to be using sine. So the sine of 37 is equal to y divided by 20. So y is going to be 20 sine of 37. So next we need to plug those in our calculator. Make sure when you plug that in your calculator, you are in degree mode, because if you're not in degree mode, this isn't going to work out for you. So we plug those in. I find out that x is 16 newtons, and I find out that y is 12 newtons. There's your example.